Greetings, everyone. It's 1 p.m. Eastern Time, and that means it's time to kick off the first of our CoCoRaHS Weather Talk webinars. Hi, I'm Henry Regis, your host, CoCoRaHS new series today, and we're glad that you're able to join us for what we hope will be an educational, informative, and somewhat entertaining hour. What is Weather Talk, you ask? Our aim with Weather Talk is to bring you a series of monthly one-hour webinars featuring experts in the fields of atmospheric science, climatology, and other pertinent disciplines. We hope to explore topics such as lightning, clouds, weather and health, tornadoes, radar, and a whole host of subjects over the next 24 months. Each series will feature a presentation from a guest speaker. After the presentation, we will open up the webinar for questions from our audience, which our guests will answer live on the air. So without further ado, let me introduce today's webinar and our guest presenters. Today's webinar is titled Snow, Love It, Hate It, It Still Falls on Us All. Our first presenter is state climatologist, founder of CoCoRaHS, and a snow lover since he could pronounce the word as a child. From Colorado State University, Fort Collins, Colorado, Nolan Doesken. Our other presenter is the state climatologist and state coordinator of CoCoRaHS in the state of New Jersey, and soon to be fellow of the American Meteorological Society. From Rutgers University in New Brunswick, New Jersey, Dave Robinson. Both of our presenters have been fascinated with snow for their entire lives and will share some of their knowledge and experiences with the CoCoRaHS community. So with that, let me turn over the mic to both Dave and Nolan.
Hello there, this is Nolan, and we're in the process of transferring the slideshow over. Look at that, looks like it's working. Dave, are you there?
I'm there. Good afternoon or morning, everyone.
Okay, and we've got people from all parts of the country. Some it's morning, some it's afternoon. Let's just get going. I'm in the mood for snow. We had a little bit here in Colorado, big blizzard going on down in the southeast part of our state last night. I was just curious about how you responded to the first question that we posed. And of the folks that are registered for the webinar today, it looks like the plurality have been with CoCoRaHS for over 3 years. We appreciate it greatly. Quite a few of you are just in your first year or just over a year. And then I'm happy to see 11 of our attendees today have just signed up and are just getting started. So it's good to see we have quite a variety of experience with us today. Let's look at snow. The best way to talk about snow is to think about snow, and with the help of some great photographs, let's look at snow, and this will help us get in the mood. Go ahead to the next slide. That looks like New Jersey. Ooh, this looks like the mountains of Colorado in the snow back in 2003. I want you to take a good look at that Weber grill and watch what happened after several hours of heavy snow.
Don't forget to look at that split rail fence behind, too.
Oh, yeah, look at that fence in the background, too. It's going to give you a perspective on what sort of a snow this was. Step back again. Okay, there you go. You see that snow adding up. Next. And let's go one more. Oh, that was a doozy of a snow back in March of 2003, nearly enough to cover that 4-foot fence, 4 to 5 foot fence, and totally swamped that Weber grill. You wouldn't know it if you hadn't seen that original photo. That was a doozy of a storm we really loved. I want you to just be thinking as we talk today why we care so much about snow. I mean, for me personally, for Dave as well, it was something that I was thrilled with from just about the time I was born. Loved playing with it. I grew up in central Illinois, didn't see that much of it, but I treasured every flake that occurred. We care about snow for a number of reasons, and we don't all like snow, but we have to care about it and deal with it. Next. Transportation issues, obviously one of the foremost issues. So many of us have to keep trying to travel whether or not there is snow. We only get to slow down during the worst of the storms. How's that for a journey over Trail Ridge Road in Rocky Mountain National Park? That was my first year as the assistant state climatologist for Colorado back in the 1970s. And then, of course, there's our airport experiences with snow. Some of those are nightmarish. I'm sure we could all tell some stories. Next. And I don't know if any of you work for a school district, but one of the real challenges is when do you call the snow day? When do you keep school in session? And there's a whole lot of scheduling issues pertaining to the quantity, the timing, and the intensity of snowfall. Next. Yeah, is that our post office there? I think they weren't doing so well that day. Next. Oh, and recreation. A few Colorado shots there, but while snow slows us down, snow also gives us great delight, and we become masters of enjoying playing in the snow and making a big industry out of that. Next. I don't think, Dave, you don't get too many of these in New Jersey, do you?
Not too often. Our mountains are a little lower.
But Colorado has, unfortunately, leads the nation many years in the number of avalanche fatalities. But dealing with mountains and heavy snow brings to bear public safety, but public safety is an issue even on level ground. Just snow and ice is a hazard we all deal with. In terms of commerce, snow helps some. It's an industry for some. It slows down many other industries. For agriculture, it's a water supply, but it also is a great hindrance at times. Next. And for weather forecasting, obviously that's what many of us think about first and foremost. I didn't have a chance to update the slide to today's snow forecast and warnings, but take the weather.gov website will be showing you all the winter weather watches and warnings at any given time. And this, here, let me bring my mouse. There we go. Yesterday it was New Mexico, across the panhandles into southeast Colorado. Today it's gone on into Kansas and heading eastward. But every day for most of the winter you'll see watches and warnings in some portion of the country, and forecasters paying close attention to what's coming, and then they look to pay close attention to our reports and how much snow has fallen. And that's where I think most of us on the phone today are CoCoRaHS volunteers. That's where your reports will be used by the Weather Service in validating where it snowed, how much, and how good their forecasts were. Livestock, wildlife management, another application of snow. Next. One that you may not think about until you get the monster snows, but the weight of snow is a big issue. And for that, we need accurate measurements of the water content and the snow-water equivalent. That was here in Fort Collins. That same beautiful snow that we looked at the Weber Grill, that snow flattened the roofs of a number of our buildings here in Fort Collins and in other parts of the Front Range. And every year, there are buildings that collapse under the weight of excessive snow. Water resources, snow is a water supply. When it melts, it becomes a source of flooding. It becomes a source of beneficial water. Next. And in fact, Dave, you might want to mention what you're looking at here.
Well, this just shows you CoCoRaHS observations from last January 31st, when we had built up quite a snowpack based on a record snowy January for the state. And it just shows you the value of your observations, because there'd be nothing without these observations. Now, it's only a subset of you who may be measuring snow water equivalent, but it's so useful. And you can see totals of 2-3 inches of water equivalent, which is so important to know for the flood forecasting, the potential of a flood threat. Fortunately, this snow was well behaved, melted slowly, and we did not have any subsequent flooding.
And some of you have heard the rumors that CoCoRaHS is expanding into Canada. That's true. That's going to be happening very soon, and it's going to be happening because of the importance of snow and the hydrology of snowmelt and the flooding they had last year. This is our river coming out of the mountains that comes through Fort Collins, carrying a great deal of snowmelt, almost enough to put it on the road in this picture. And I'm just thinking that I have a cursor that I'm looking at the screen, but I don't think you get to see my cursor. So Dave, why don't you talk about the great squeeze play?
Okay, great. Thanks, Nolan. Just want to do a little Weather 101, but with just a couple slides to remind you why we get snow here, why we get winter storms that deposit oftentimes some hefty amounts of snow. And it's essentially what we call that middle latitude squeeze play, where we're that battle zone between cold polar air, generally dry air to our north, and moist, mild air to the south, and they tend to converge over the lower 48 for the better part of the winter season. Today, in the last couple of days in the southwest, but stay tuned. That's likely to change multiple times over this coming winter and bring storms to all corners of the nation. So we've got this squeeze play of air masses, and riding between these air masses is the jet stream. And when the jet stream, here as expressed in the North Atlantic Oscillation, negative and positive mode, well, when it's in the positive mode, you can see what we call zonal flow. And in that case, the warm air kind of stays where it belongs and the cold air where it belongs. And you tend to get weaker storms. They're somewhat starved of moisture as they come across the United States. And it's a rather calm, benign pattern. But on the left, where you get this sinuous movement, this meridional circulation, we call it. And that's where cold air gets deposited where it often doesn't sit, and some warm air can intrude far to the north. And that can create a very stormy scenario. And the one on the left is what we've seen in February of 2010 in the eastern U.S. and late December and January of 2010 into 2011, both of which resulted in record snows coming up the East Coast. So that's just some very basic dynamics of this very complex weather climate system in which we live. Here's an image showing you how these low pressure systems develop as the warm air intrudes on the cold air and vice versa. You spin up an active mature low center, and it tracks along that jet stream just like pearls along, if you will, along a necklace. Every couple days there's a storm threat generally in one part of the nation coming from another part and heading out into the Atlantic. And it's these low pressure systems at that confluence between the cold, dry air to the north and the warm air, moist air to the south that brings us these storms, and with them, particularly on the northwest quadrant of those lows, the snows that we known to love and sometimes deal with. Now, where do those low pressure systems go? As I said, they ride along the jet stream, but it depends if the jet stream is in a zonal mood, if you will, then you might get something akin to an Alberta clipper. But when it becomes quite sinuous and you get into meridional position, you can move a Colorado low out, similar to what we're seeing today, or up the East Coast with some ferocious nor'easters off the East Coast of the United States. So those are preferred storm tracks, typical as the slide says, but there's all kinds of variations on these rules. And what does it add up to? Well, you can see our national annual average snowfall. I could say that national annual average was getting buried with snow, and thus you only see the top of the figure, but that's just some editing I didn't do right. But there's your annual mean snowfall. Somewhat of a zonal pattern, especially across the central part of the country, but you'll notice the mountainous west is anything but zonal and anything but a regular configuration, obviously elevationally dependent, and you can see a little bit of that in the Appalachians down through West Virginia, areas where multiple feet of snow fall every winter. You can't quite see the white there, but that would be greater than 72 inches for the season in white, and then it grades to the gray, 48 to 72 inches, and as you go up the ladder there, you can see the colors decrease as you head south across the country. A lot of snow, as we said, can fall in any given event. Nolan's already shown some tremendous pictures. The question is, and we'll talk a little bit about measurement later, but I'll let you figure out what the question here is. Yep. How many feet of snow fell in your neighborhood in the last storm or last winter? Here's the number of days. Now, this figure may surprise you. This is something that was compiled by the National Climatic Data Center, a part of NOAA. The number of days when you have snowfall of greater than an inch, when you're going to have to go out there and measure greater than or equal to an inch on your snowboard or however you have to measure it in your yard. And you might think it snows dozens of times each year, an inch or more. But if you notice, though only the white areas on this map do you measure an inch or more of snow more than 20 days during the year. And most locations, it's roughly 5 to 10, maybe 15 days a season that you're going to get out there and measure the new snowfall that's coming down. Still, it's quite a bit of work, as you know, when you get out there and have to measure the snow. This gives you an example of a map where we were out measuring snow. Many of us were out measuring snow in New Jersey just about a year ago when we had a major blizzard come up the East Coast. And you can see these are primarily CoCoRaHS observations. There are some National Weather Service spotter obs here as well. And of course, some of you are both. And you can see the areas in yellow had more than 2 feet of snowfall. And it grades out to the western part of the state where less than a half a foot fell. Very unusual pattern where the state was split right up the middle. It has nothing to do with elevation, nothing to do with latitude. It had everything to do with the precipitation shield of this storm, which fell at the temperature of about 20 degrees Fahrenheit. So it wasn't a matter of being rain to the west and snow to the east. It just simply didn't snow much off to the west. But you can see the value of snow observations, how important they are to get out there and make these obs, and that's where you guys are such wonderful contributors. This is, as a matter of fact, just boiling it down to what CoCoRaHS showed. This is a map that's produced on the fly off the our weather site, our state climate weather site, using CoCoRaHS obs. The other map was done a week after the snow. This was actually done in an automated fashion as people enter their observations every morning. The map grows with observations. Another NCDC figure showing you the 2-day storm, 50-year return period. So this is the type of event you're likely to see only once every 50 years statistically. And you can see the dots in red are 30 to 59 inches of snow measured over a 2-day period. And you'll see that in the northeast and in the mountainous west. Meanwhile, in the central part of the country, generally a 15 to 20 inch snow is very unusual in the northern half of the plains, and something on the order of 10 to 15 inches of snow is considered pretty rare in the southern plains, or central to southern plains. Here comes the next question that you guys answered when we put out the call for this webinar, and that is does the annual snowfall across the contiguous United States continue to decrease? Well, you answered 59 thought it was decreasing, 56 said it was not decreasing, and 3 of you were smart enough not to answer at all. Anyway, here's what the answer is. And Nolan's going to be surprised to see this one, because when we first looked at the answer, well, I was thinking the answer is really it has not decreased. But then I started thinking it depends on where you look and how you look at the numbers. So let's look at some figures here. Well, I'll hand it back to Nolan for a second.
Well, yeah, this is, thank you. This is our own weather station on the campus of our university here, where we've been maintaining very careful daily observations all the way to the late 1880s. And we saw ups and downs is what's dominant. It's highly variable, and we've seen some of our snowiest years were the late 70s into the early 90s, then a little taper off after that, but I failed to update the graph. We had our second snowiest year on record just 2 years ago, and then one of our least snowy years on record just last year. And everywhere you go in the country where we happen to have the benefit of long-term data, you see different historical stories. Some of it's observational. Most of it is the climate in action. Back to you. Oh, well, I'll talk about this one as well.
Take this one, yeah.
Yeah, and one of the things I'm interested in is how does the seasonal precipitation in the form of snow vary across the country. For most parts of the country, as you were moving here through December, we're just ramping up into the major snow season. When you're in places like where we're located on the Front Range of the Rockies, however, we actually have a double-peaked snowfall season that you don't see. Let's see, I'm not seeing a Denver or Fort Collins on this particular graph, but we have most of our snow in the fall and spring, and then a sort of a lull in the winter. So everywhere you go in the country, you see a bit of a different picture, but in general, you peak in December, January, and February.
Yeah, I thought it was interesting. Minneapolis there kind of has a coreless snow season where you get about equal amounts from November through March. So there's another example of a variation.
Right.
So really quite a neat. By the way, you may be interested in looking at station totals from around the country. Every year I write an article on the snow season for WeatherWise magazine. It's a slow publication process, and I just finished last season's article, which hopefully will appear in the January-February issue. And you can see that for last winter, of the 37 cities around the country we poll, virtually every one of them had above average snowfall. The one that was least of their normal average was Denver, just down the road from Fort Collins.
Sure enough.
Okay. Now, I want to introduce you. We're not showing a lot of slides with words on them because we want to zip through, and you don't want to read a lot of slides. But we're looking at seasonal totals across the country. I was involved in a study led by Ken Kunkel, who's a climatologist who's been all over the country in various locations. Now he's at the National Climatic Data Center as part of a consortium group. Anyway, Ken led this study with myself and others looking at trends in 20th century extreme snow. We identified a number of stations, over 400 stations, which we thought had credible long-term weather records 50 years or longer back into the past. And these are locations of these stations. And here, just cut quite right to the chase, and you can see the reference to the paper in the Journal of Climate at the bottom of this screen. We looked at those time series, as you can see across both of them, from 1900 to 2007, where the number of snowfall events in the exceeding the 90th percentile, so the top 9 out of 10 to 10 out of 10 storms by year, those vertical bars, and then an average, smooth average with the heavy dark bar. I should also say in that top figure, the dashed line are the number of stations that were available to contribute to that analysis, and the numbers are on the right axis there. But on the left is the percent area coverage with greater than 90 percentile snowfall. And the bottom is less than 10 percentile. So the big snows up top, the lighter snows down below. And you'll basically see the result here is in the last several decades, there's been a decline in the number of large extreme snowfalls. You can see that beginning, say in the 1980s after the snowy 70s and down and really dropping off. When it comes to lower snowfall extremes, there hasn't been much of a change. So I said the take-home picture story here is that the extreme excessive snows are decreasing, but there's no major change in the lower 10% of snows. They're happening just about as frequently as in the past. So not glaringly large changes in the amount of snow falling across the country, but a little bit on the lower side. The higher ends are becoming a little less frequent. This figure is out of a paper that I was co-author with a gentleman named Ross Brown in Environment Canada. And what we did here was update a figure that appeared in the last Intergovernmental Panel on Climate Change report. We've updated it for the upcoming assessment report that will be out in 2014. We've just had this published in an online journal called the Cryosphere, if you'd like to look that one up. And what we've done is combine satellite records since the late 60s of snow extent across the northern hemisphere continents in March and April in these cases with station observations from pre-satellite era. And you can see over the long term, March and April snow cover has been decreasing in extent, and the more recent decades during the satellite era, it's been decreasing at an even faster clip. So we're going here to snow on the ground, not snowfall. We'll be visiting a little bit more about snow cover in just a few minutes. But let's go back to one more snowfall image, and that's New Jersey statewide total. We've just, not from one station, but from a group of stations over the last century, we've just compiled this. And the take-home picture here is that there hasn't been any change in snowfall across the Garden State over the last century. Sure, it's had its ups and its downs, but nothing of great note in terms of a trend. Interesting to note that the last 2 winters are the snowiest back-to-back winters in the entire period of record. But you can also notice, as Nolan said, our snowiest year in 95-96 was followed just 2 years later by one of our least snowy winters, and we've had a couple of others of those along the way. So a great deal of variability in the year-to-year snowfall, from just a couple of inches to upwards of 6 feet or 5 feet. We looked at that with regard to snowfall versus temperature, and notice the temperatures are inverted, so it gets warmer as you come down and snowier as you go off to your right. And you can see that generally our snowier winters occur when the average temperature for the winter is colder, but only up to about 30 to 40 inches, or to about 10 inches above average, and then it just levels off. And you actually have some winters, like 2 winters ago, that were a relatively mild winter but had a heck of a lot of snowfall. So the rule is that snow becomes more it becomes greater when you've got colder temperatures up to a certain point, and that may be due to the fact that you need to get moisture into the picture to produce a lot of snow. And as we'll see later, a little hint to one of the questions later about being too cold to snow. Well, the fact is, when it's just at the freezing point or a little below it, you hold the most moisture in the atmosphere, and that can help it snow the most. Lake effect snow. Some of you live in that area. Most, if not all of you, are interested in it. And this was another part of the Kunkel and Company study where we did a paper for Journal of Great Lakes Research looking at snowfall off the Great Lakes, lake effect snow. This is a satellite image showing you where lake effect snow is most common off Erie and Ontario. The surrounding areas are snow-free, so it really helps you highlight where the snows come off Ontario, Erie, and off Huron, and falling in Canada as well. I'll let you interpret that on your own.
Ha, ha, ha.
And here's the take-home on that. We see an increase in snowfall downwind of the Great Lakes. It's most significant, interestingly enough, in the western lakes of Superior, Huron, Michigan not as much so. It's not even in this figure. But you may have heard about this in the past, that snowfall is increasing in the lakes or downwind of the lakes. The fact is, our conclusions are that it is increasing, but not as much as some earlier studies showed, because they weren't using the best snow data. We think we've got the best, and we see it increasing. It may be just because the water on the lakes has gotten warmer, just slightly warmer, and that allows more moisture to get into the atmosphere and become snow once off the lakes. Again, they might be saying that up in the Great Lakes, although they can get brushed by some remnants of hurricanes at times. Then there's something else you may have been familiar with that I've been involved with folks down at the National Climatic Data Center and my colleague Matt Gerbush here at Rutgers, and that's the Regional Snowfall Index. You may know this as the NESIS, the Northeast Snow Index, which spun off something that came out of Cosin and Ussolini more than a decade ago. Well, we've taken this and refined the index, created an index that we hope is comparable between 6 NOAA climate regions east of the Rockies. We're still dickering with what to do with the Rockies and west. This is an index, a very simple index that's based on the amount of snow that fell and the distribution of population. So it is a population-weighted figure. The colored areas are the 6 regions we've created separate indices for. This shows you the population density. The lighter the shading, the denser the population. And that is population density, not mental density, because otherwise it wouldn't make New Jersey look very good. Anyway, why do we do something like this? Well, here's an example of the snowfall in the map on the left for the January 96 storm that came up the 95 corridor from Virginia into southeast New England. But on the right, it shows you the interstate highways that were impacted by that storm. And you can see how those in red had 30 or more inches of snow. Those in dark blue had 20 to 30 inches of snow. So there's some real practical applications to mapping this snow and using geographic information systems to add railroads, hospitals, interstates, you name it. You can layer it along with the amount of snow that fell so you can get a sense of the impact. This shows you the top 20 southeastern storms that were used to help create this index and the distribution of snowfall for these storms. A Category 3 storm on the bottom and a Category 5, which is the highest category, on the right. A Category 5 storm should only occur about every 50 years or so. And then here's another fun slide that a friend of mine at the University of Georgia sent along. I think this defines what they went through last winter when they had an unusually persistent week of snow cover. By the end of the week, I think that's a mother on the right whose kids were home for school for the entire week. Here's a couple more diagrams showing you what a particular pattern looks like in the southern southwestern area there of a Cat 5 storm, and a lower category storm. Now, it didn't even snow in part of that area for that Cat 5 storm. So this is a regional index, and we're even looking to do a national index. It doesn't necessarily tell you what happened in your backyard, but for broader commerce purposes, and you have to remember that NOAA is part of the Department of Commerce, this can give you an idea on the severity and impact of snows as they fall over the course of a winter. And this is looking at a time series of how these top 50 storms were distributed by decade and region. So we took the top 50 storms in each of those 6 regions and parsed out by decade when they occurred. And you can see there was some peak, a little peak early in the 20th century, a big peak in the 60s, stayed high in the 70s and 80s, and hasn't dropped off all that much in the 90s and the past decade. So we're getting a lot of these bigger storms. I know you're going to say that contradicts what we said with an earlier figure that we're getting fewer big storms. But you have to remember this is also population weighted, and the snows just happen to be falling where a lot of people live. And you look at the Northeast and the number of their storms, say in the 60s and in the last 2 decades. These are the number of Category 5 storms per decade. You can see the 20s were a big decade for that, except in the Northeast. And then you see that the 80s and 90s had some whoppers as well. And this is just been launched, a website down at NCDC, and you can see the URL at the bottom here. But you can simply just kind of Google the regional snowfall index or Google NCDC if you don't have a pad and a pen handy. Next question. Too cold to snow. 70 of you thought that was the case. 44 said, nope, it's never too cold to snow, and 4 did not answer. The answer to this, it can become too cold to snow. No, it cannot. It becomes more difficult to squeeze a lot of moisture out of a very cold air mass. An air mass, it can snow at 40 below. Take your choice, Celsius or Fahrenheit there. It's just that the Clausius-Clapeyron relationship shows that there's much less moisture in a colder air mass than one that is slightly milder. So you can put a lot more moisture, thus a lot more snow in a 20 to 30 degree Fahrenheit atmosphere as compared to a minus 40 or minus 50 Fahrenheit atmosphere. But it could still snow even at those cold temperatures. Not only is there less moisture in the atmosphere at those cold temperatures, but generally the dynamics to form a storm aren't too great. You don't have any warm air too close in those cases, so it's hard to spawn a storm. But it can snow at some very, very cold temperatures.
Just moisture from your tailpipe, for example, people who might have spent some time in Fairbanks, just driving your car, the moisture from the tailpipe is enough to form clouds that almost immediately start producing small snow crystals when the temperatures are very cold. So you can have an auto-enhanced snowstorm, not just a lake effect one.
Right. And now we're going to talk about snow cover just quickly. This is a scene from my backyard. You may have seen it earlier when you couldn't see that house well behind it. Covering of snow on the ground is pretty important for the climate system. The question is it too cold for snow cover? Or is it too much, or do you need is there snow on the ground because it's cold, or does the snow on the ground help make it cold? And the answer is yes. Both come into play. And this is a satellite image of a snow-covered Northeast. The areas that are forested are darker. There's still a lot of snow under the trees here in the White and Green Mountains and in the Jersey Pinelands. It looks a little brown up here, and that's because there was hardly any snow here 2 winters ago in mid-February. That was the time when the mid-Atlantic states here were buried under several feet of snow. Looking across the country here through the Central Plains, you can see a swath of snow that was deposited with no snow to the north on the ground and no snow to the south. And here's the departing storm that dumped this snow over Nebraska, southeastern Nebraska, and Iowa, a little bit of Minnesota. A little more humor to make sure you're awake still. Fun one I like to show. This is a NOAA map of snow across the United States. Every one of our states, even a little bit of the Florida Panhandle, had some snow cover that morning in 2010. And for proof, there's a snow-covered scene in Athens, Georgia on the right. These charts are made every day by analysts at the National Ice Center. And they appear on the mysnowcover.org website. The latest, this is yesterday's snow cover across the northern hemisphere lands. The areas in gold are snow covered. The areas that are white are not. This shows you the November snow extent. I invite you to visit snowcover.org and click around to your heart's content at the page. Actually, that's 2 days ago. This was a little closer up on the snow extent. That actually, I should have changed this because I updated this morning. This was yesterday's snow map. But you might say, well, what's the big deal? Should there be snow there? Shouldn't there be snow there? Well, we actually created a departure map. And the areas in red, as of yesterday, should normally have snow cover on that date, on December 19th, and did not. The areas in blue normally are not snow covered on December 19th and did have snow cover yesterday. So you can see that there's some real negative departures in snow across the United States. And the map on the left verifies that there's very little snow on the ground across the U.S. Here's a question. The association between snow albedo, the reflectance of snow, and surface air temperature is an example of a positive, negative feedback, neutral, or there is no association. It seems like positive ruled with no association second. The answer is it's a positive feedback. And explanation there is as you get snow, increase the snow, it increases its reflectance of the surrounding surfaces, and your surface air temperatures will decrease. With decreasing surface air temperatures, you'll get more snow. That will further enhance the albedo, which will further lower the air temperatures, and more snow. Now, it doesn't go on forever, and that's in part due to this second feedback. When it snows, you have high pressure over a cold, snow-covered surface, and you can get a polar outbreak, and that can help spawn storms, which will deposit more snow. However, it can go negative late in the season when your high pressure means clear skies, and with the February and March sunshine, it helps start melting the snow. That lowers the albedo, which warms the atmosphere more, which helps melt more snow, and you get that feedback in a negative sense. Anyway, here's another example of the chicken and egg question of cold and snow. These areas in brown in February 2002 had below average snow cover. The areas in red on this figure had above average temperatures, and you kind of have to stand on your head to look at this. But you can see in Eurasia it was very warm with well below average snow cover. In the U.S., it was in the east, it was below average snow cover and above average temperatures. In the west, it was a little above average snow cover and slightly below average temperatures. So there's your association between snow on the ground, sitting on the ground, and temperature. I'm going to skip over this because time's getting short and it involves a little explanation, but there's our polar bear friend lounging out there. So next question leading into that is the extent of snow cover over northern hemisphere lands has decreased in each of the last 4 decades in which season? And some thought fall, many thought winter, a few thought spring, and some of you thought, the majority, or the plurality, so plurality of you all, boy, I'm tripping over my own word, all seasons. Well, what's the answer? It's spring. Spring snow cover is the one that's decreasing. Here is a decadal look at snow anomalies. And you can see fall snow cover in the 70s was above the long-term mean, in the 80s was below, 90s about average, a little above in the last decade. Winter snow, really very little variation, but it's bounced from above to below to below to above. But look at spring. Well above the long-term average, still above it, below it, and well below it. Spring snow cover is decreasing across the planet, and this falls right in line with what climate models suggest should be happening as the Earth warms, that we should see the effects first in spring with an early demise of snow cover. And there we go. I won't promise this is the last cartoon, but it might be. I can't remember. So on and back to Nolan.
Oh boy! And some of you
finish us. Take us home.
Let's come down the snow-covered home stretch here, and many of you on the call today may have already tried to get on or been on one of our snow measurement webinars, and you've heard us discuss the challenges. The fact of the matter is measuring snow is harder than measuring just rain. Next, please. Especially if you encounter something like this when you go out to do your measurements, or your gauges are almost totally buried in the snow. A few people are finding that in the Oklahoma Panhandle. And we put so much emphasis in snow measurement in CoCoRaHS, mostly because we know, Dave and I and the many we work with know how critical the data are, but I used to just love watching snow, being out in the snow, and now I'm always thinking about, man, how much did I get? What's its water content? It takes a little fun out of it, but not that much. It's still pretty fun.
There you are.
Oh, there I am checking out a snowboard, and I think, Henry, wasn't that your backyard, I believe?
That's it.
And again, reminding people that it's good to have a snowboard. We encourage you, if you haven't already, to view our snow measurement training materials. We'll be posting the latest webinars that we've done will be posted on the CoCoRaHS YouTube site. I do want, as I recall, Christmas is right around the corner. I think we have a Happy Holidays week going on right now. This gives you a perspective historically on what parts of the country normally have a white Christmas. For our Colorado Rocky Mountain area, most of the mountains have white every year or almost every year. The northern plains, northern New England, but look at those gradients across the rest of the plains. Last year, and I think there's some people from Tennessee on the call, there was a beautiful snow on Christmas Day, just a perfect idyllic snow in both Kentucky and Tennessee on Christmas Day. That's not going to happen every year, as you can see from these statistics. And I just want
a whole bunch of pictures. Nolan's going to narrate now.
Yeah, we'll just come down the stretch enjoying snow and appreciating just how beautiful it is, how challenging it may be to measure, but nevertheless how beautiful, quite remarkable a material it is. So dynamic. The crystal structure is always changing. A snow crystal that lands on your sleeve today will look totally different if you looked at it in the snowpack tomorrow. So just enjoy. We appreciate you being a part of the webinar today. This is your time to start typing in your questions if you haven't already, because we're going to stay. Oh, there's the albedo effect. When something sticks that's not white sticks out of the snow, guess where the snow melts first? Around the base of a tree trunk, around a rock, whatever. The reflectivity of snow and its impact on the whole climate system, just a remarkable and important phenomenon. Isn't that neat? The snow accumulated on the little branch above the ground, but not on those warm rocks. Snow is just incredible and to be enjoyed. Yes, it's slippery. Yes, people can slip and fall, but as best you can, enjoy it. That was a funny one that we had here. We had extreme drought in 2002. Many things were closed because there wasn't going to be enough irrigation water to keep the athletic fields open. We turned around to having a 3-foot wet snow, and I thought that was quite ironic. Anybody around for the 1949 Great Plains blizzard? That was a picture we caught. Well, I didn't catch, but we have in our archives out in northeast Colorado from that 1949 blizzard. And of course, the avalanches, which the Rocky Mountains experience, flatlands generally not, but there have been avalanches and a few fatalities in New England. Dealing with snow and traffic, it's beautiful, but it's a pain. Talk about a pain is when it starts to move around. You get the road cleared only to have it blow shut again. That's a part of life in the northern plains. Cattle don't care for it too much. That was just a few years ago here, and that was on our campus, a heavy, wet snow that took down a tree. We had much tree damage just in late October of this year when our trees still had leaves on it when we got our first heavy, wet snow.
That's something we shared in New Jersey because I was in Fort Collins to see that, and then came back to Jersey and got to see the same thing in New Jersey in late October.
That's right. And we both, there we are enjoying snow. We both wish you happy holidays, and may you enjoy many more snows in the winter, this winter and the winters ahead.
Well, thank you so much, Dave and Nolan. Really very informative slideshow there. And I'm going to ask folks, if you have any questions, to go to the control panel on the webinar and go ahead and type those in. If you would put your name and state to begin with, and we will take those and answer them right now on the air. I haven't seen any yet, but we're going to hang tight here for a few minutes.
So while folks are typing, Dave and I probably have some questions for each other. Dave, how much snow there on the campus of Rutgers so far this winter?
Officially 3 inches from that heavy October snow and nothing since. It was more in the way of 4 to 6 inches in central Jersey and upwards of 1.5 feet in the highlands of New Jersey from that heavy wet snow. But nothing since that. Nothing since that time.
Wow.
You've had 3 or 4 good snows.
We started off big with an October snow, then another November snow, both on the order of 8 to 12 inches. And in fact, already by mid-November, we had as much snow as we had the entire previous winter here. Last year was fascinating. Our mountains west of here, only 50 miles to our west, were having one of their snowiest winters on record, while we were in the shadow, what's called the rain shadow, the snow shadow, the downslope effect. Although storms were all of Pacific origin, we hardly got any what we call upslopes when moisture comes in from the east. We had a nearly snow-free winter at the same time that our mountains were having one of their snowiest ever. Now, what about last winter, Dave, when you had that big post-Christmas storm? Were you right in the middle of the gradient there in the Rutgers vicinity?
Yeah, good question. I live a little west of campus, and I'm on the east side of my 55-square-mile town, and I had 17 inches. And less than 10 miles away on the west side of town, they had 6 inches. And we're not talking elevation or anything like that. It was right down the spine of the state where you just watch those radar echoes backing in off the Atlantic and just hoping they'd make it over. And eventually they did. But over here on campus, a few more inches fell, and up along the coast, another 10 inches. So that was quite a remarkable event that just crippled the eastern half of the state.
Gentlemen, I'm going to interrupt you. We've got a bunch of questions that have come in, and we're going to extend the webinar a little bit here so we can try to get to many of them. Let's see what we've got here. There's a question here from Kansas, and they want to know, is there an update on the La Nina status? They've had 8 inches of rain since November 1st.
Oh, that's been an interesting one to watch here. You know, last year La Nina and the Climate Prediction Center and many climate forecasters anticipated dry across the south and cold and wet across the northern tier of states in the U.S. And for the western two-thirds of the country, that really worked out. And this year the La Nina continued, which is the cooler than average sea surface temperatures off the coast of South America out into the central Pacific, and the early indications were we might follow in that same pattern. And this year, so far, over the course of the few weeks of early winter, it's been quite different, with storms coming across the southwest, Texas getting so much beneficial rain right up into Kansas, which has had the extreme drought conditions persisting as well until just these last few weeks. So right now it's out of sync with what was anticipated. Dave, comments from your side of the country?
Yeah, here in the mid-Atlantic states, last year at this time, I was telling everyone that 7 of the last 7 La Nina winters all had below-average snowfall. So while it's not a take to the bank, not a bad odds in climatologic parlance. And then along came our 9th snowiest winter of the past 100 years. So now this year, with the weak La Nina that's out there, I'm saying, well, 7 of the last 8 winters had below average snowfall. So, you know, the storm track tends to go up through the Ohio Valley in a La Nina winter, which puts the East Coast on the warm side of storms. So we'll see if that holds. Last winter it did, except for 5 weeks from December 26th till Groundhog's Day, when the North Atlantic Oscillation ruled in a negative sense, and it just dumped snow on us. So, you know, it's a tricky system out there, this climate system, and truth be told, we don't know exactly what will happen, but the odds would favor a below-average snowfall winter for the Mid-Atlantic this year.
Yeah. Thanks, guys. I have another question here from an observer in North Carolina. She writes, albedo is a new term for me. What is the best website to learn more? Do you guys have any suggestions on that?
Oh, that's a real good question from someone who actually had the word albedo in his PhD dissertation of snow-covered land. Albedo is simply the reflectance of the ground. A dark soil will absorb upwards of 90–95% of the solar radiation that impinges on it, whereas a snowpack, a fresh snowpack, may have an albedo of 80 or 85, meaning that only 10 or 15% of that solar energy is absorbed. I would, I haven't thought about this. I might look for a general climate text, or there's probably a good Wikipedia article on albedo to help explain things. But it all has to do with the reflectance of any surface, but here we're talking about the Earth's surface, as it's associated with solar radiation, visible light.
But that's part of why you hear so much talk in the media about research in the Arctic and the Antarctic about shrinking ice packs and changing snow cover, because, as Dave pointed out, it does have interesting feedbacks that are really important to the whole climate system.
Okay, guys, thanks. Here's another question. I recently heard that lower than average snow cover in November is a harbinger of a warmer than average winter. Is that related to the positive albedo feedback? Many thanks.
Okay, that one, this is actually a little bit of research I'm involved with, and I've sat on a few committees of scientists studying this for their degrees. There is a little bit of statistical evidence that a heavier snow cover, so I'll go the other direction, a more extensive snow cover than average over Siberia in the fall feeds back through the atmosphere to the North Atlantic in the subsequent winter, making the North Atlantic Oscillation negative, which would give the East Coast more snow and cold. Opposite sense, less snow over Siberia in the fall, a positive NAO during the winter, and a milder eastern United States. Yes, there's some statistical significance to that. Yes, it has a little bit to do with the albedo effect, but there's other effects of snow cover. It insulates the ground, and it shuts off any milder ground from radiating warmth into the atmosphere, because by the time you get to October and November up in Siberia, there's not a lot of sunlight. So it's not all about albedo. It's about all the different characteristics of snow and the impact they have on the atmosphere above a snowpack. I think there's a little credence to this finding that goes back about 10 years or so, but there needs to be a little more research to connect all the dots. It's a great question.
Thanks. I've got a couple more here. We're going to try to go through these and try to get most of them answered. Where we have here, okay, back to El Nino and La Nina again. Can you give it, I know you guys touched on this, can you give a general picture of the impacts of La Nina and El Nino on snowfall patterns nationally and regionally?
I can address the West a little bit. In the presence of a La Nina, we tend to have a more active northern storm track. When I say northern, I mean coming in across the Pacific Northwest into the northern Rockies, and we'll see in strong to moderate La Ninas above average snowfall and snow accumulation over the northern mountains into the central mountains, and then below average, as was the case last year for some, but not all of the West, because last year the storms made it all the way into Southern California, but they didn't make it into Arizona, New Mexico, and of course Texas, Oklahoma, Kansas. So again, La Nina, typically active storm track and above average snow over the northern into the central Rockies and then across the northern plains, below average across the southern Rockies into the southern plains. Dave, you can take it across to your side of the continent.
Yeah, taking it across the central and eastern part of the country with a storm track through the central plains up through the eastern Great Lakes, Ohio Valley. It tends to give a La Nina, would give the areas in the northern plains and Great Lakes pretty good snow season, pretty on the heavy side. Whereas areas to the south and east of that area, below average snow. And El Nino isn't great for snow just about anywhere through the southeast, the Midwest, and up the East Coast, except when you get a little bit further north where even if temperatures are a little above average, it can still snow. And of course, there are exceptions to that rule. you can sneak in a major snowstorm during an El Nino because you tend to have a pretty active storm path off the southeast Atlantic. 1983 up the East Coast is a great example where there was one major snow of the winter. It deposited about 2/3 of the annual snowfall in the mid-Atlantic in one storm, and that was about it. So La Nina tends to be below average relatively consistently. El Ninos can have surprises, but generally aren't very heavy on the snow side.
But keep in mind that for much of the country, a few snowstorms, sometimes just 2 or 3 snowstorms, will be the difference between a snowy winter and an unsnowy winter. And sometimes there's just little runaway random storms that don't quite follow the pattern.
And that's why some people will say it's better to judge the severity of winter by the duration of snow cover rather than exactly the amount of snow that falls.
Good point.
Okay, here's another question. Are precipitation, including snow forecasts, getting more accurate these days? Why or why not? It would seem like not really, but not sure statistically.
Well, I think from the Western point of view, and again, I've been on the job here at Colorado State University since the 1970s. During that time period, as recently as 20 years ago, there wasn't much skill at all in predicting storms more than 3 to 4 days in advance. Now we've had several skillful forecasts of storms, such as that one in 2003 that I showed pictures of, that were fully a week in advance. There are still surprises when it comes to snow. We've had some already this winter, but overall, from a Western perspective, I see much greater skill in prediction. I'd be interested, Dave, in your take, because you'd have to deal with that blasted rain-snow line on the East Coast that is nightmarish to the forecasters.
Yeah, no, there are still problems. There's no question about that. I like to say the devil's in the details of the last-minute part of the forecast, and as the storm unfolds. But there's no question that a 3 to 5 day forecast today is similar to what a 1 to 2 day forecast was 20 years ago. They've gotten that much better. I loved your answer about them being able to pick up the threat of a storm a week in advance. They picked up this October snowstorm, which was about as rogue a snowstorm as you can expect, several days in advance. And in the past, you would have never seen that. So while it still is an imperfect science, it has improved significantly.
I got to tell a quick story pertaining to that 2003 forecast, since I showed the pictures of the deep snow and the collapsed roofs, etc. Because of the forecast and the confidence of the forecast, we were able to send out emails to CoCoRaHS volunteers saying that this storm could be way deeper than what your ability to catch it in the CoCoRaHS gauge were, and that you might need to have some other equipment on hand. And as a result, we had some of our volunteers out buying 4-inch diameter stovepipe, 4-inch diameter PVC pipe, trying to get larger collectors to get samples of the snow, and it worked out great. We got some incredibly good observations considering the extremeness of that storm.
Well, thanks, guys. I got a couple more questions. We're gonna go probably about another 10 minutes here. Tom from Massachusetts. His question is that, has the high that was in the south this summer, I assume that's the Bermuda high, moved eastward to cause less snow in the northeast?
Yeah, that was the Bermuda and Sonoran as well. It was just linked all across the southern part of the country and brought them just a devastating drought and heat. You know, the pattern's been quite variable. Nothing is really locked in the last couple of weeks. It's quite a migratory pattern. There hasn't been any blocking up to our north. There's a high been off the southeast, but generally it's been a very transitional phase. So when it gets cold, it hasn't stayed cold for more than a couple days. More often than not, the cold air has stayed locked up to the north. So it's tough to get a real handle on this pattern for the winter so far, except one of pretty frequent transition.
And here's another question, and I'll answer this one. People want to know, will the slides and this presentation be available online? It will be. Hopefully we'll have this up sometime next week, and you can review it again, and we'll have all of these on a website as we have recorded them. Here's a question from...
And let me add, you have our email addresses at the end, so as you view this in subsequent times, feel free to send us questions if you have them.
And also remember that as volunteers, you're contributing data to help us continue the research that we're all fascinated with. The data that are collected by volunteers. When it comes to snowfall, we don't get much data from any other source other than human volunteer measurements. Yes, the satellite observations, which Dave can address, are extremely useful, but without ground truth measurements of the actual snowfall and its water content, we would be up a creek. So thank you, all of you, for the data you helped collect.
Here's a question from BJ in Arizona, and they want to know, what is the chance the low desert will have any snow this year?
Oh, well, from the normal La Nina forecast, you'd predict very little chance. But as you know, I've been tracking Phoenix temperatures. I believe the last month you've been something close to 5 degrees below your averages for this time of year, and you've had some sub-freezing temperatures, and some of these storms have put snow down on the surrounding mountains. So I wouldn't rule it out completely based on what we've seen so far.
Okay, I've got two measurement questions here. This is one from Milton, and he says, why do you measure total snow on the ground to the nearest half inch, and the National Weather Service only wants snow on the ground to the nearest inch?
I'll take that one, because I was the one that did that and sort of stirred up the National Weather Service, and says, because both Dave and I helped the Weather Service update their snow measurement guidelines back in the 1990s. But I recommended that simply because observers are able to observe snow depth, especially for smaller snows, more accurately than just the nearest whole inch. And it's really in the less than 4-inch range that it's sort of significant. I can tell a difference between a ½ inch and an inch, or an inch and a half and 2 inches, and that information is somewhat useful. Now, the 1-inch guidelines of the Weather Service make a lot of sense most of the time, but the fact is we can sometimes measure better than that, and we would rather try when we can, and then round to the nearest whole inch if we need to.
Here's Dave in New York, and Dave says, rain, freezing rain, and blowing snow all in one day. Then the snow melts. How to measure? That's the question he asks.
Dave, you see that more than me. I'll give it to you.
Well, the first question is, did the snow accumulate on the ground? Because if the snow never stuck on the ground, you just call it a trace. If the snow does stick on your snowboard, and hopefully you have a snowboard, you would measure, we recommend measuring the snow at when it attains its greatest depth. If it's an inch and then it turns to rain and it starts washing away, well, you had an inch of snowfall. There's one other take on that. What if it snowed an inch and then it went to rain and it melted off and then another inch fell later in the day? There, since you had a break between the snowfall events, you can add them together and you would have 2 inches for that day. This is really, it's a great question, because there's an art to doing this, but you know, art can have structure, and you should use your best judgment. Ask us if you have any questions. But again, I would suggest measuring the snowfall at its greatest accumulation during the course of the event as being your snowfall.
And that's in terms of freezing rain. If you happen to have freezing rain, if it falls all as rain and freezes on contact, even if it accumulates, that is not snow. It is not reported as snowfall. It does contribute, however, to your total depth of snow on ground, which includes ice layers as well.
We've got one last question, and this is from Fred in Virginia. And Fred says, how should you report the snow water equivalent, SWE, when you have a white rain event where it snows most of the day and you may accumulate ½ an inch of snow, but you have 0.75 inches of precip in the gauge? So 1/2 inch of snow and 3/4 of precip in the gauge.
Well, your precipitation measurement will be the water content of all forms of precipitation that fell and accumulated in your gauge. So your daily precipitation amount is just the water content that was in your gauge, which would be predominantly rain, but then the snow melted down as well. But your snow water equivalent, which would go down as a core sample, that is simply the water content of what snow is still on the ground at your time of observation. So any rain that fell would not be included in that snow water equivalent. It's only the water content of the snow that remains on the ground if you're doing your total snow depth snow water equivalent.
Okay, I'm going to make one more question, and then we're going to cut it off for today. And this is an interesting one. They want you guys to be real honest on this. Do you guys read and pay attention to the Farmer's Almanac?
It's got some good stories in it. That's about all I'll say. Except there have been a couple of little statistical studies, and I hope no one from the company is on the phone right now, that show you're better off flipping a coin. The fact is you simply can't project weather conditions on a daily basis or a couple-day basis, months or a year or more in advance. There's just no validity or no skill to such forecasts, despite what some may say.
I used to get a copy every year just because I knew that one or more news reporters would call, and it just helped if I saw what was written, so I wouldn't have to interpret their questions. But I'm fascinated at the climatological expertise of the authors, however, because they describe scenarios in many ways that sound so plausible, and it's because they understand the climate, and they describe things that match up with the climate characteristics of storms as they progress across the region. So there's this sense of confidence you get in it, even though there is no predictability, as Dave says, months in advance, even weeks in advance, on the daily progression of storm systems across the country.
Yeah, I hearken back to something I said about an hour ago when I talked about that string of pearls of storms, and I said every couple of days, every winter, there's going to be a storm threat somewhere in your neighborhood. And by neighborhood, it could mean, for me, from Albany, New York down to Richmond, Virginia, or something like that, that there's going to be a threat of a low-pressure system of some kind coming through. So you can pretty much just get out your calendar and every 3 days say it's going to be cloudy with a threat of precipitation and just bring that through and just shift it a little bit. And you could probably convince yourself that you're pretty correct in your forecast in not too much time, where in essence you'd just be taking climatology and applying it to the calendar.
Well said.
Well, gentlemen, we want to thank you for being part of our webinar today. We really appreciate you taking time out to join the CoCoRaHS Weather Talk webinar series. We will be posting these on our website. We'll be sending that out in the message of the day sometime next week, where we will have all of our webinars archived. And we want you to join us if you haven't already registered. There's still some spots out there. We'll be running the registration next week again for the remote sensing what satellites can see, our second presentation in our Weather Talk series. That'll be held on Friday, January 13th at 1 p.m. Eastern. So on behalf of myself and the staff here at CoCoRaHS, we thank you for joining us today, and we hope you'll join us again.